Okay, so first, one quick announcement. Oh, I have a question. How many people came to school yesterday, advising day? Oh, that's a good number. That's a good number. Okay, so another announcement. This one is about money. There are two $600 scholarships available to GCC students only, care of the faculty and the professional staff union. Here is what you need to be qualified. Have to be a currently enrolled student here, must have at least 12 credit hours completed, not counting this semester, must have at least a 2.5 GPA, and then finally must have contributed to the improvement of workers' rights, equity, and justice. To show that you have done that, there is an essay part of this. So if you feel like you meet all of those characteristics, throw your name in the hat. Two people at GCC are going to win $600 each. You write an essay explaining how you have contributed. Yeah. So if you want the details, just let me know right after class. I can email you this document. Any questions about it? Okay. If you win, I get 10% for telling you. It's like a finder's fee type thing, just for the record. Okay. I'm going to take it before they give you the check. I'll just take my $60 right off the top. Yeah. Okay, so today we are going to talk about factoring trinomials. And next class, it's more factoring of trinomials. So factoring is going to be a very important word for us in the coming weeks. And then, what's that? It is not. So Monday's quest, so we have factoring today, we have factoring Friday. Monday's quest covers classes 19 through 23, which is not today. So the quest is on that. We have finished the material for the quest. We don't have a full period review scheduled for this quest. We lost 3 different classes because of snow days, so some stuff has to disappear. But there are sample quest problems in the packet. You will find them if you hunt around a little bit. There are YouTube videos of me going through all of those things. There are full color PDF solutions for those problems up on Moodle. The same resources we've always had, you still have. But the stuff that we do today and Friday is not on the quest. Okay? Any questions on the calendar? Then let's begin. Number one, here towards the bottom of the page, can we start with Glenn? Okay, thank you. We'll go around to Melanie. Number 2. Okay, and so I've just added one phrase here. Lobster claw was the Sandy phrase for this double distributive law or FOIL. Just a way to multiply things that look like these examples down here at the bottom. So we're going to do number 3 now, multiply and combine like terms. We're going to write out the first one, but for the other 3, we're going to try to combine like terms in our head. So let's try to do part A right now. So whether you do FOIL or lobster claw or whatever, what do we get when we multiply the first things together? That's x squared, okay, and then we'll do the other part of the lobster claw or outers, 7x, and it's a positive 7x. And then the inners is a positive 2x. And then the last, or the other part of the lobster claw, 14, positive 14. And then those 2 terms in the middle combine. And that happens quite often. X squared plus 9x plus 14. Questions on that one? So what I'd like you to do, let's just take the next minute or so, do the other 3. But if you could try to omit this step right here and try to just get those 2, like say those 2 terms in the middle out loud and then combine them and just write down the combined thing. Just give that a shot. And check your answers with your neighbors. So let's take a look at just the answers here. I'm not even going to look at the original problems, but just my answer key. And I want to just point out a few things. I'm interested in the signs. So that has some signs that are positive and positive. Part B, positive and positive. Part C, positive and positive. Same thing for D. But then we see something different. We see a positive, we see a negative and then a positive, right? So something was fundamentally different about E than for the other ones. And so you might take a look, well, what was different? What's different about E? Y minus 8, Y minus 1 had two negative numbers in there, right? Negative 8, negative 1, whereas on the previous page, I think they were all positive numbers. Okay, how about this? Minus and a plus, is it still the same? Two negative numbers, is that where we came from? It is. Okay, so we're starting to kind of try to develop some intuition here, a little bit of pattern recognition. The next one is a plus and then a minus. Is that the same as the one we just saw? No. The one we just saw was minus and then plus. This is different. It's a plus and then a minus. And what happened? I'll put this in green. It was a plus and then a minus. And what were the signs that it came from? It was a plus and a minus. Okay, that's good. So maybe that's kind of a different pattern. Let's look at the next one. I'll do this in blue. Plus and then a minus. Did it come from the same thing? Plus and minus. Okay, super. And let's look at the last one. We'll go back to yellow. Minus, minus. What does that come from? It was a minus and a plus. Well, that actually is kind of disturbing to me because up here we have one positive, the 11, and one negative, the 4, right? And when we had that one positive and one negative, we ended up with a plus and a minus, right? Over here, we still have one positive and one negative. The order is reversed, but you guys could have written that the other way, or this could be written the other way. It would still be the same answer. But somehow, one minus and one plus turns into minus minus. That's disturbing. That's different from what happened over here. One positive, one negative turned into a plus minus. Over here, it turned into a minus minus. So there's some pattern that's going on that's maybe not as easy as we were thinking in the beginning. Let's move on to number 4. I think we're over here to Ben.
In this section, we're going to take a problem that's already been foiled and unfoiled. For example, we can factor x squared plus 9x.
Okay, so the goal is to unfoil. We're never going to say unfoil. Everybody calls that factoring, but you just think somebody foiled two things together. That's going to disappear. Somebody foiled two things together and got x squared plus 9x plus 14. We want to try to undo their work. What did they foil together that it became x squared plus 9x plus 14? Now, in this case, the answer is at the top of the page because x squared plus 9x plus 14 was the first answer you got. So you can look at part A, the problem itself. That's going to be the right answer to this problem. But usually you're not so lucky to just have it right in front of you. So let's go down to number 5. Number 5? Number 5, subtab? Okay, let's see if we buy that. Thinking back to the very first problem we did together here, part A on the previous page, where did the 14 come from? 7 times 2. That's why it's 14, yes? So definitely we need two numbers that multiply together and give me 14. Well, there's actually a couple of choices. So let's write down the choices. So one of the possibilities was 7 times 2, right? What's the other possibility to multiply and get 14? Yeah, so 2 times 7 is another possibility, but it's the same, you know, like it'll give you the same exact answer as this one, because we know when we multiply like 5 times 3, it's the same as 3 times 5. So we want like really two fundamentally different numbers, and it's 14 and 1, right? So at this point in the game, pretending you don't know the answer, because you just did this in part A, let's pretend we don't know which one is the right answer. How could we check? Well, we could just multiply each of these out and see, does either one of them give us this? That's the question. If we find one that gives us that, then we got it right. So if we go ahead and foil together the first, x plus 7 times x plus 2, what's the first? X squared. Outers is plus 2x. Inners plus 7x. We're going to do that together in our heads. 9x plus the last 14. Good. That's the winner. But it could just as well have been the other one was the winner. So let's check that one. First, x squared. Outers plus 1x, inners, plus 14x altogether, plus 15x, plus, multiply the last, 14, always multiply. Okay, did that one, we were looking for the 9x in the middle. Over here, we got 15x. That's not the right answer. Okay, so here's one method to factor, is you look for numbers that multiply to give you this last thing. We definitely need to get 14 as the product of two numbers. And then you just try all the possibilities, right? You just write out all the ways to build 14, and you FOIL them, and you see which one gives you the 9 in the middle. Let's try number 6. If we want to factor x squared plus 13x plus 12, we want two numbers that multiply and give me what? 12. Everybody see that? Start from the end. It's kind of weird. Start from the very end. We want two numbers that multiply to give me 12. I want you guys to write down the possibilities. There are actually 3 different pairs of numbers that multiply to 12. Write them in the parentheses. Something times something is 12. There are 3 different kinds of choices. And don't just take the same numbers and swap their order, because that's going to give us the same thing. You want really fundamentally different numbers. So what multiplies to 12? 12 times 1. Somebody else? 3 times 4. Somebody else? 2 times 6. Those are the possibilities. You don't have to write them in this order, but those are the sets of numbers, right? Nothing else gives me 12. Okay. So then to check which one works, we're going to FOIL each of these together. So you have 3 FOIL problems. Go ahead and do all 3 of those. Firsts, outers, inners, lasts. Okay, so we got 3 different FOILs. We got 3 different answers at the end, right? They differ only in the middle, only in that part in the middle. Which is the right answer? We were trying to get this plus 13x. Which one gave it to us? Is the 1 and the 12. That might not be the first one you had, but find the thing with the 1 and the 12. That's the one that gave you the 13x, right? The other ones gave 7x and 8x. Those weren't the right answers. Okay, so number 7, we'll go to Teresa. Keep going. Okay, let's see if we believe that. Definitely we want the product to be 12, right? That 12 is the last thing that we see. And why did the 12 times 1 work? It's because when you FOILed and you did the outers, what did you get? 1x, and the inners you got 12x, and you added the 1x and the 12x, and you got 13x. Well, if we just say exactly that, but don't say x, you added the 1 and the 12, and you got 13. So we're looking for 2 numbers that add up to 13. 1 and 12 added up to 13. What did 3 and 4 add up to? The 7 in the middle. So here's a nice little shortcut. We're looking for 2 numbers whose product is the last thing, it was 12 in this case, and whose sum is the middle thing, 13. And it turns out that's true all the time. So that's how we're going to do these. In the next example, we're trying to factor x squared plus 9x plus 14. That's one we just did. We want 2 numbers whose product is which one? 14, and whose sum is 9. Next one, to factor, this is a brand new one. X squared plus 12x plus 20, fill in the blanks. 2 numbers whose product is something and whose sum is something. Fill in the blanks with those 2 numbers. What are the 2 numbers? 20 and 12. I'm going to ask you guys to really put plus signs, even though you don't need to because they're positive. But we're going to really focus on the signs because they make a lot of difference in these problems. Sam. You don't need to put the plus signs in, but I'm going to put them in there just so we really think of these as signed numbers. Positives and negatives, we really have to be aware of those. Okay, number 8 says let's fill in the table below to help us factor the same one we just talked about, x squared plus 12x plus 20. Fill in the blanks at the top just like you did before. The product is still supposed to be positive 20, and the sum is still supposed to be positive 12. And now we're going to make a little table. We're going to find all the different ways to factor 20, and don't worry about the sum, just factor 20. Give me two numbers that multiply to 20, 20 and 1. And I'm going to try to go out of my way to include positives and negatives every single time. So that's positive 20 and positive 1. Another possibility to multiply to 20. 10 and 2, and we're going to put them both as positive. Other numbers that multiply to 20. Good, 4, 5. Are there any other numbers that multiply to positive 20? There are. There's some negative numbers that multiply to positive 20. Give me some negative numbers that multiply to positive 20. All of those, but both negative. If I had negative 4 and negative 5, that will give me a positive 20. Now, it turns out you don't need to necessarily include them all, but I'm just highlighting that you really got to pay attention to the signs, and you do have maybe more freedom with these numbers than you might have thought of because two negatives multiply to something positive. And now we're just going to do the sums, and it's as simple as just adding the two numbers that are in the first column. Positive 20 plus positive 1, positive 21. Go ahead and write in 3 or 6 sums, depending on how many numbers you have in there. Okay, we have all our sums. Again, looking at the top of the column here, what did we want the sum to equal? 12. You find the one where the sum is equal to positive 12. It's right there in this one. It could be in a different spot for you. And you're done. You just have to write the answer. X, X, that's how they're all going to start. And then I'm going to copy those numbers, and now you see why I focused on putting the plus signs in there, because that comes over. It is a plus 10 and a plus 2. That's the answer. Is it the same one? Is this okay too? Same thing? Yeah, so if you have a negative there compared to a negative here, those are different because that's a negative 10 and that's a negative 2. But as long as you just copy these numbers, it doesn't matter the order you wrote them, just bring them right over here with the signs, pluses and minuses. Okay, any questions on this one? Product, sum. Okay, let's look at the next page. I guess we just answered this one. It's not something to do again, but just for us to write down the answer. So we just factored this thing, which means write it as the product of two things in parentheses. So what did we say it was? Good, that's it. Questions on that? Okay, let's take a look at this little mnemonic, this way to help us remember the product and sum. You're going to think of writing a PS at the bottom of a letter. This might be a little bit outdated. Do you guys still write letters? Sometimes. A postscript. Postscript. Yeah. So something you stick at the end of a letter, PS, something, right? Okay, so PS, product sum, PS. Good? But you got to read it right to left, which is a little bit opposite. If I just read this thing in English, this looks to me like it says sum product, which is fine, but I need you guys to focus on it the other direction. You start by thinking about two numbers whose product is 20, and then you hope that you can find some of those that add up to 12. The reason you don't start the other way, give me numbers that add up to 12. 6 and 6, somebody else. 11 and 1. 12 and 0. Good, keep going. 2 and 10. 3 and 9. Are we tired of doing this? Do we see how many more things there are that add up to 12? But numbers that multiply to 20, there were only 3. 1 times 20, 4 times 5, 2 times 10. It's only 3 possibilities. We haven't even finished here, right? 5 and 7. What else could we do? We got that one. And that doesn't even include some negatives. How about this? Negative 3 and 15. What do you get when you add those? 12. That's a terrible way to go about finding the answer. So you really want to focus on the product, which is why even though it's written not left to right, which is the normal way to read, I came up with something that says P and then S, not S and then P. Product sum. Okay, let's try number 10. In fact, why don't you guys just try number 10? You're going to fill in the blanks at the top of the chart. You're going to fill in the possibilities. Put pluses and minuses. Every number needs to have either a plus or a minus in front of it. And then once you're done, write the factored form. Check with your neighbors on this because there's no answers. Okay, so let's come on back together, even if we're not all finished with those 3, but let's just make sure we got the basic idea. In part A, what's the product supposed to be? 15 with the positive and the sum, positive 16. And I'm just going to write P and S, PS. Now, some folks try to tackle these both at once, thinking of both properties at the same time. Two numbers that multiply to 15 and add to 16. It might just come to you, but I'd encourage you just to fill in the left-hand column. Just find any numbers that multiply to 15. There's not that many. What are they? 1 and 15. I'm going to be real nitpicky and put plus signs in front of both. What else? 3. And 3 and 5, right? Those are the only numbers, although both negatives would also work for us, but everything's going to be positive here. And I didn't think about 16 at all. You don't need to tackle both parts at the same time. You just factor 15, easy. And now it's just a matter of hopefully finding one that gives you the right sum. 15 plus 1, oh, fantastic, that's the winner. It's 16. The other one gives you positive 8 when you add them. That's not it. So I'm going to circle the first row that gave it to us, and then I'm going to write down the answer down here. So this is something that I saw there were some people not writing in, so let's do that down here. Every one of these things is going to look like parentheses, parentheses, with an X in the front of both. And all of the good work that you did just tells you what goes next to the X's. What number goes next to the X? Plus 1, and then plus 15. That's it. You grab the two numbers that you found, put them next to X every time. Questions on part A? Okay, part B, again, I'm going to write PS, right to left. What's the product supposed to be? Positive 24, sum. Positive 11. Then we fill in, and we just think about numbers that multiply to positive 24. Don't worry about the sum. What multiplies to 24? 24 and 1 is good. Somebody else? Two numbers that multiply to 24? 6 and 4, great. 3 and 8, great. Any others? 2 and 12. That's not hard to do, right? Just come up with the exhaustive list. That's all of them. And then we just add, and we cross our fingers, and we hope that one of them gives you 11. When you add the first row for me, what do I get? That's 25. That's not it. Next one. 10. Having trouble with those two today. 10. 10 is close, right? Close is absolutely worthless. It's not going to help me in the least to have 10 when I want 11. It's either going to work at perfectly 11 or it's not. What's the next one? 11. That's the winner. Last one, just for completeness. 14. And I will circle in red my winner. 8 and 3 gave me the 11 I wanted. And then if you didn't do it yet, go ahead and write in the 2x. What goes next to the x's? Plus 8 and plus 3. It's okay to have the other order, plus 3 and plus 8. Okay, and then the last one, we're just going to write the final answer for this one. Anybody have a final answer for this one? It's wait for part C on, are you guys on 11? We're still on 10. So it's a plus 5, plus 3. Any questions on this one? These are going to get harder. We've just done the easy ones because they all have positives. Any questions on it so far? Okay, 11, we'll go over to Dave. Okay, so finally now we have some negative signs. How does our product sum business change? Not at all. Let's fill in the blanks. Again, I'm going to start by putting PS on the top of each of them. It's always the same. Product sum. Read it from right to left. Okay, in the first one, part A, what's the product? 4 is not enough for me. Positive 4, thank you. What is the sum? Negative 5. Aha, sum is supposed to be negative 5. Two numbers that multiply to positive 4 and add up to negative 5. Let's just start filling in. Two numbers that multiply to positive 4. Positive 2, that seems natural. Good. Any other two numbers that multiply to positive 4? Good. 4 and 1. Yes? When I add these, what kinds of numbers are we going to get? Positive numbers. What did I want? I want a negative. I want negative 5. Neither of these has any chance of working. But this is where we take advantage of the fact that there's another way to multiply two things and get a positive, and that's if they're both negatives. So it's the same numbers, but make them both negatives. Negative 2 times negative 2 gives me positive 4. That's what I want. And the other possibility is a negative 4 times negative 1. And somewhere down there, you're going to find the sum that you wanted. Sum here is positive 4, positive 5, negative 4, negative 5. That's the winner right there. Go ahead and write down the two parentheses. We've got our answer in that last row, but you got to finish by putting the two parentheses. And I see that I didn't leave you guys enough room to do these. I apologize. But let's fill it in. XX. What are the right numbers here? Minus 4, minus 1. Any questions on that? And hopefully now you can see why I stressed so much about the signed numbers. I want every number up there to have a sign, even though we never write the sign for positive numbers, because we have more control than maybe we think. Positives and negatives are both allowed. Okay, PS on the next one. What's the product supposed to be? Negative 8, and the sum? Positive 2. This is different from any of the ones that we've seen before. That's the first negative product that we have seen. How do you multiply two numbers and get a negative? That's right. We need one of each. 1 plus, 1 minus. Okay. Let's start filling in some numbers. Factors of -8. All right, so you're just giving me the final answer. I don't want that first, so we'll give me a -8 and +1. We gotta build up the suspense, right? We're gonna put different possibilities in. Negative, good. Let's write that here. -1 and +8. Same or different from the first row? Is it? Are those the same numbers in the first row and the second row? Is it the same result? Those are not the same numbers. In the one of them, the 8 is negative. And the other one, the 1 is negative. They're different numbers. When I add them, do I get the same thing? What do you get in the first row? Yeah, when we multiply, we get the same thing, but we get different things when we add them. So you absolutely need to list them both. They're different. What you don't need to list is something like +1 and -8. That's the same as the first row, right? That's just literally picking the two numbers up and changing the order. That's not going to affect anything. That's the same thing. Okay, we haven't found the answer yet. I was looking for +2. Still looking for numbers that multiply to -8. So we could have, which one? -2 and -4 and +4. Good. And one other possibility. +2 with -4. Good. Those are the only numbers that multiply to -8. Add each row until you find the winner. So for me, the winner is circled in red. And then again, there's really not space, but try to squeeze it in if you can. They all start XX to parentheses. It doesn't matter which one goes in which. What does matter are the signs. So for me, what are my two numbers? -2 +4. Those are my answers. Just as well, we could write those same numbers, but in the other order. What does that give me? +4, -2. Both of these are exactly the same. What you got to be careful about is taking the negative and putting it on the other number. That changes things. But the order doesn't make any difference. Okay, part C looks different than all the ones we've seen. This is the first with both negatives in it. So let's write down, what's the product supposed to be here? -12. And the sum is -1. Good. Right? Even though it's not written, there's an implied -1 there, yes? I also want to highlight, this isn't -1x that goes there. It's just the -1, right? Okay, bad news, gang. There are a lot of factors of -12. We're probably not going to be able to fit them all in the table, but we'll just list until we try to find the right one. Two numbers that multiply to -12. 6 and -2. That's good. And I'll just go ahead and add them up. You don't need to fill in the table forever. You just need to fill it in until you find the magic sum. What do I get when I add those two? +4. Is that the right answer? No, we want a -1. Okay, two other numbers. -4 and +3. And -1 and +12. Let's go ahead and add those two rows. Middle row, -1. That sounds good to me. We'll do one more. Last row is +11. And again, you don't need to go forever. You need to go until you find the sum. Then you stop. Okay, so in this one we get x -4 and x +3, yes? Okay, Number 12, we are back to Drew. Okay, so let's fill in the product sum. And it seems like, you know, every example we've done so far would lead us to believe that every one of these things you can factor. You just do the process and you find the row that works and that's it. But the fact is, a lot of times it doesn't work. So what's the product supposed to be? Positive 12, sum, positive 4. Go ahead and write in some numbers who multiply to positive 12. I can think of 3 different pairs. So what could we do? 1 and 12, both positive. Also, 6 and 2, both positive. 3 and 4. Yeah, and then the same exact numbers, but both negative, all good. And then we'll do our sums, and we'll pick the one that equals positive 4. First sum, 13. Next one, 8. Last one, positive 7. Which one equals positive 4? None of them. But there's nothing else we can do. We've tried all the numbers that multiplied to 12. Although, you know, Sam is right that we could do all these numbers with negatives, but if you make them both negative, all that's going to do is make your sum negative. It's going to be the same numbers, but all negative. It's not going to get positive 4. So what does it mean? It means we can't factor x squared plus 4x plus 12. There's no way to factor x squared plus 4x plus 12. So we say that x squared plus 4x plus 12 is not factorable. You could also say it's prime because a prime number is a number that what? Can't be factored, right? 15 isn't prime because it's equal to 5 times 3. But 7 is prime because there's nothing you can do for 7 besides 7 and 1, right? So if we call 7 prime, we can call this x squared plus 4x plus 12 prime. Can't factor it into the product of 2 things. Okay, some observations, and then you guys will have plenty of time to do the group thing. So I'm going to start off with this very generic looking trinomial. Trinomial is something with 3 terms like this guy has. So ax squared plus bx plus c, as general as we can make it, a, b, and c are all numbers. We'll get plenty of practice with this soon enough, but for example, in this one, how much is a? It's 1, right? Because it's 1x squared, and 1 is the number touching the a. So a is 1. B is the number touching the x. What's b in this case? 4. I'm going to put a positive sign in there just to be consistent. And then c apparently is the number that's just sitting at the end, positive 12. Okay, so some observations here. If a is equal to 1, was a equal to 1 in the one we just did? Yes, 1x squared. Was a equal to 1 in every example we've done today? Yes, they all started x squared plus x squared minus, but it was always x squared. So if it's x squared, like every example we've done today, where did we go? Then 2 numbers whose product is c and whose sum is b. C is the last term, b is the middle term. It's the same PS that we did all day today. If c is positive, then the 2 numbers are both the same sign as b. If this guy is a positive, then you want 2 numbers with the same sign as that. Let's see if that plays out in the examples we've done already. If the last number is positive, then the 2 numbers you want are the sign of the middle thing. Here is a positive, and according to that rule, I wanted 2 numbers that were both negative. Is that what happened in the final answer circled in red? We had 2 numbers that were negative, right? -4 and -1. Okay, is this guy positive, the last one? No, the thing we just said doesn't apply. Is this positive? No, doesn't apply. Let's keep going up. Looking for the last one to be positive, is it? Yes, we wanted 2 numbers that were positive, is that right? In red, 2 numbers that are positive? Yes. Same kind of thing over here. If the last guy is positive, you want two numbers that are that sign. We didn't write out the details, but that's exactly what we had. +5, +3. Okay? So if you're into memorizing things, there's something you can memorize. I'm not into memorizing that. The only thing I know is product sum, and then I make my chart. But I'm just trying to give you some general things that are true if you want to try to cut down a little bit on the grunt work. Next page. If C is negative, then the two numbers have opposite signs. If C is negative, if the last number is negative, then the two numbers you seek have opposite signs, 1 plus, 1 minus. Let's see if that was true in these examples down here. Was the last number negative in this one? No, doesn't apply. Was the last number negative here? Yes. What I'm saying is it makes no difference at all what this guy is. We always seek one positive and one negative. If that last thing is negative, you want one positive and one negative. Is that what happened in red? One positive, one negative. This guy is negative. We want one positive and one negative. Did we get it in red? Yes, one positive and one negative. So if the last one's negative, it makes no difference at all what that sign is in the middle. Automatically, you have 1 plus, 1 minus. Do I have that memorized? No. But I know that if we need two numbers whose product is -12, you better have what kinds of numbers? Two numbers whose product is -12. Better be what kinds of numbers? One positive, one negative, right? It's the only way to multiply to -12. Okay, and then the last thing says if A is not 1, that's the first term. I'm going to give you an example where A is not 1. 3x squared plus 4x plus 1. We didn't do any like this today. How much is the A in this case? It's the 3. It's the first number. If A is not 1, it says good luck, and we will tackle these beasts next class. These are much tougher. Unfortunately, the product sum thing just doesn't work. If it did work, what would we be seeking? Two numbers whose product is +1 and whose sum is +4. Okay, what are the only numbers whose product is +1? Is 1 times 1, right? Or -1 times -1. Do either of those give you a sum of +4? No. But if I give you this, 3x plus 1 times x plus 1, and I just ask you to, where did we go? If I asked you to FOIL that, could you do that for me real quick? Go ahead and FOIL those two things together. What do we get? We get the 3x squared plus 4x plus 1. Even though the product sum thing didn't work, there's some different stuff going on. I'll give you a different technique on Friday. But for tonight's homework, none of them will have a 3 in the front of the x squared. They're always going to be just a single x squared. Okay, so group work is there. Whole bunch of factoring to do. Looks like 9 examples. Nope, 12 examples. So don't forget, every final answer is going to look like this. 2 parentheses. That's what you're after. Sam. This factoring is not on the quest.